it's Richard here from Intelligent Advisor IT Consulting with another in our irregular series about JavaScript extensions. This time out, we're going to be looking at entity container control extensions. Before we begin, some really important basic concepts. When we talk about a control extension, we're talking about a JavaScript file added to the resources folder of your Intelligent Advisor project. This file must conform to the extension API. That is, there's a structure, a basic layout of the file that you have to conform to. Each file has a specific type key, which helps you identify what the file is for. Within the extension, since it's JavaScript and since the API gives us access to them, you'll be able to access objects and methods such as the interview object, such as the control object, depending on the kind of extension that you're building. There are strict rules in place for what we should and shouldn't do with an extension. This is all about transforming the customer experience. This is not about changing the outcome of a business rule. So this is all about the user interface layer. So I just mentioned that you're going to be working with a particular set of template structures. Each extension has its own predefined template. Where do you get the templates from? Well, you can write them yourself from experience. There are a few on the online documentation, or you can use a tool like the intelligentadvisor.com code generator to generate boilerplate code for any of the extensions that you might need. So back to the focus of this chapter, the custom entity container. You'll see that the title here is custom entity container with no spaces. That's because that's the key that you will find in a JavaScript file if it is managing an entity container. Take a look at the screenshot on the right hand side. This is a standard entity container placed in an interview screen. We have the entity, and then I have added two attributes. So I've added the name and the price attribute. So technically speaking, an entity container contains entity attributes. The entity instances, so the rows of data, might be coming from a previous screen where the user has collected the data, or they could be inferred from an Excel file, or they could be loaded in. The point is that an entity container does not let you create instances. You can only view or edit them. So if you're looking to create or delete, it's not an entity container you need, it's an entity collect, which we'll see in a forthcoming chapter. The entity collect can contain list drop-downs, inputs, checkboxes, labels, and other stuff. It's essentially a container, and inside the container are entity attributes. So there's a very specific scope. So writing code for an entity container, you're going to be writing essentially three pieces of code. One piece of code called the mount key, which is where you're going to initialize your container. Perhaps you're going to draw some pictures or add some HTML to the page. The update, if anything needs to be updated when things in the interview change, that's where you're going to be writing your code. And finally, the unmount, where you're going to clean up, disconnect any connections, null any objects, generally tidy up. The entity container in the API gives you access to the interview and the control objects. So you'll be able to use interview methods. You know, there are so many of them, like interview, get extension data, and the control object, you'll be able to get values, you'll be able to get type, get options, and so forth. Before you start any of this with an entity container, it may be that's not what you're looking for. If you're looking to create or delete records in an entity instance set, it's not a container you want. You want an entity collect. If you just want to customize the buttons then you have a specific set of extensions for customizing and add and remove instance buttons. If you just want to draw a picture based on some data in a container, then it's probably a custom container, which we looked at last time out. Or if it's just one item on an entity container you want to change, perhaps you want to replace a standard input control with something different, well, then it's just an input control that you need. Back to our standard entity container. So here we have an entity container with 3 attributes. The important thing to realize is that you as a developer, when you decide to take on board this custom entity container with 3 attributes in it, you will be responsible for creating all of the code to display the container and its contents. So in a simple example, you're going to create a div and then you're going to create 3 inputs per row of information. You're going to say to me, well, Richard, I already have a bunch of extensions. I have input extensions. I have drop downs. It doesn't matter. You can't nest Intelligent Advisor JavaScript extensions. You can't put one extension inside another. So if you're going to write an entity container extension, it's got to contain all the code and the logic and the graphics for your container, including the 3 attributes. So this is the basic idea is here is a mount, and you can see that I've created a div and stuck it on the page. So I've started my container. Of course, what happens next after that depends on me. I could write it all from scratch, or I could use, probably at least for the user experience part, existing libraries like JS Grid or JQ Grid or Glide.js. Maybe I'm going to do something really sophisticated and draw some pretty pictures, so I'll use something like D3. It's up to me. A very common model you'll see in interview screens is that the developers will use the control properties to pass information to JavaScript. So you can see in this case, we're passing information such as the entity name, and we're passing also a name, which allows us to identify the control in the code. So in this case, it might be that the entity helps us identify which entity this container is looking at. Of course, you could hard code it all, but if you want to write code that you can reuse in many different places, having properties like this to pass in valuable information can make your code more reusable. So in the code on the right, it could be that I'm going to scan through the list of entities looking for a particular entity ID. Once I've found my entity, what am I going to do? Well, you're going to iterate through the instances and maybe draw 1 row per instance. In the code on the right, you can see that I'm iterating through the instances and I am populating a JavaScript object with various pieces of data, and then I'm pushing the object into an array. This is a very common model because many of the external libraries like JS Grid and JQ Grid want an array of objects for the data for their display. So in this case, it's been hard-coded with 3 different attributes, one called the name, one called the price, and one called the size. And it simply iterates through those, adds them to an object, and then pushes the object into the array. So if you're using an external library like JS Grid or JQ Grid, it gets really easy now, because if you look in the code on the right-hand side, you'll notice a data attribute, which is just referencing the array of objects that was created on the previous page. JS Grid, which this is an example of, uses the fields of array to specify the metadata for displaying. So you'll see that we have width, title, align, and type, and so on. I guess this is the most important point. A lot of the time, it's going to be a lot quicker to leverage an existing library and pass the package data into the library. It also means that you can benefit from whatever extra functionality those libraries provide, which in turn makes your users happy. If you're going to have an entity container that provides the ability for the user to update the data, you're going to need to think about how you're going to handle the data changing. You might use, as in the screenshot at the bottom of this page, a traditional JavaScript event to then update the various fields. And the fields, maybe you are identifying them as HTML objects with their own data attributes. That's a typical model that you'll see quite a lot. If you're going to have the situation where the container itself needs to be updated because it's affected by other things that have happened in the interview, you'll need to use the update key to make sure you refresh the values. Bear in mind that if you use interview.saveData anywhere, that will refresh the page. So you might want to handle the saving of data in a different way, such as the screenshot, where you're using traditional JavaScript events. I mentioned a minute ago the benefit of using external libraries, and this is an example. If an external library offers a functionality to create a filter, well, then make it available to the user so that they can filter the data. Instead of seeing 54 rows, they can filter and only see the rows that they want. This is just one example of all the different things that you'll find in JS Grid and JQ Grid. So let's wrap it up. What did we learn? We learned that entity containers are similar to container extensions, but they make it easy for us to target entity instances and entity attributes, which makes it great for displaying rows and columns of data. If you just want to draw a pretty picture based on a set of data, then probably the container extension is the one for you. But if you're focusing on the instance data, then an entity container is definitely where you're going. In the demo which you're about to see, we'll take a look at two examples of an entity container and study the differences and how to implement a simple grid layout. So in this very short demo, we're going to look at an example entity container. This entity has 4 attributes, 2 text, 1 number, and 1 Boolean, and I've given them all names. And then I've placed them on a screen with a standard entity container, and I've added my 4 attributes. I've also added 2 custom properties so that I can pass that information to my JavaScript. The JavaScript results in a very basic layout like this with 5 rows per page of my 4 attributes, but I do have a paging utility here, so I can scroll through the 13 different rows, and I've set the page size to 5 rows. So this is an added benefit for the end user. In terms of how it's implemented, you'll see that it is a fairly standard piece of code with included, we have the ability to sort the data. We have the page size is 5. So when the user displays the information, they see only 5 rows. In our second example, we have a similar structure. We have an entity this time with only 3 attributes. And the data for this entity is actually inferred in an Excel spreadsheet. And in the Excel spreadsheet, there are 54 rows. So this is quite a considerable amount of data, which wouldn't really make it very friendly if the user had to scroll through it row by row or page by page. So this particular example leverages the capability of filtering. This is the field that is going to be used as a filter. It's just a numeric level field, and then if we go and notice, it's exactly the same setup as previously. I'm passing the entity name to the code, and my entity container looks like this. I have the familiar paging, but now I also have the filtering so that the user can filter the data and only see those that they're interested in without having to page or scroll through endless rows of data. That's it. See you next time.